Hello, my dear students. Welcome to lecture number 20 on chapter motion, and this will be the last lecture on the motion part. Here we are learning about uniform circular motion actually. So, before going to the uniform circular motion, it's better to understand what exactly the circular motion of a body or an object means. Okay, let us try to understand circular motion, which is given by this definition: the motion of an object or a body in circular path is known as circular motion. Motion of an object or a body which is moving in, or better you call it, is moving in straight line or straight path, that is said to be circular motion of the object. Assume this is a body, so which is moving in a circular path like this, so that motion of the object is said to be circular motion of the object or a body. So this is the definition of circular motion. So where do you find the examples for such kind of motion? Motion of the blades of a fan. If you are observing a fan, once you switch on the fan, you will get the blades of fan moving, which is circular, and hence we call motion of the blades of a fan is an example of circular motion. So similarly, we have motion of the hands of a clock. If you are observing the clock carefully, the hands of the clock moving in circular path. Okay, that is also one of the example for circular motion. Similarly, motion of the electrons around the nucleus. Motion of the electrons around the nucleus is also the example of circular motion. Similarly, motion of the moon or any satellite around the earth has the circular path, and hence it is also an example of circular motion. Similarly, we have merry-go-round. The motion of merry-go-round is taken as circular motion. Similarly, motion of the pulley used to draw the water is also the example for circular motion. This is how we are listing the examples for circular motion. Still we have many, but these examples are sufficient, I believe. Okay, so circular motion of a body is the motion of the body or an object in circular path, that is simply circular motion of the body, and these are the examples listed in front of you. Now we have different types of circular motion. So there are two types of circular motion. One is uniform circular motion and other one is non-uniform circular motion. Let us try to understand what uniform circular motion means. Okay. When an object moves in a circular path, on a circular path you call, when an object moves on a circular path with constant speed or uniform speed, if the object maintains constant or uniform speed while in circular path, okay, such motion is known as uniform circular motion. Okay, when an object moves in a, again you draw this, assuming this body is taking or moving in circular path, object O, which is moving in circular path like this, in this path. In moving so, if it maintains uniform speed throughout, if from, assume it is at point A, point B, point C and point D, and you take it as position O. So we have four positions here, 4 or 5 positions. So if the object maintains the same speed at point A, point B, point C point D and point O again. So such uniformity or such constant speed of the object is known as uniform circular motion of the object. So this is the definition for uniform circular motion. I believe you got this definition right. So we have again the examples, same examples, motion of the hands of a clock which is constant all the time, and hence that is also an example for uniform circular motion. Similarly, motion of the moon revolving around the earth is uniform. A cyclist on a circular track at constant speed is also the example. Similarly, the motion of the athlete throws hammer or shot put by rotating himself or herself, by that they gain constant or uniform speed. That is also an example for uniform circular motion of the object. So these are the definition and examples for uniform circular motion. And we have one more definition, that is non-uniform circular motion. This definition is very simple because it dependent on the uniform circular motion. When an object moves on a circular path, keep in mind this time, not constant speed, it is varying speed. If the object moving on circular path with varying speed, then it is said to be, or it's said to have non-uniform circular motion. So such motion in that case is taken as non-uniform circular motion of the body. So for examples, you can go to the previous one. Here, assuming a cyclist on a circular track with varying speed. If a cyclist not maintaining his speed on circular track, then the motion of the cyclist is taken as an example for non-uniform circular motion of the object or a body. Okay. Similarly, an athlete is throwing a hammer or shot put by rotating himself. So if he is not maintaining constant speed or uniform speed, then that is also an example for non-uniform circular motion. Remember, these two examples are may uniform or may not uniform. If they maintain uniformity, then it is uniform circular motion. If it is not, then that is non-uniform circular motion. I hope you got these two examples with respect to uniform circular motion and non-uniform circular motion right. Now, in these definitions, we got the word or words you may call uniform speed and non-uniform speed. So for that, we need to calculate. How do you calculate whether the speed is uniform or not? So here is the demonstration for you. Speed of an object moving on a circular path. So assuming an object is moving in circular path, we are calculating speed of it. So this will be the object O, which is moving in circular path like this, and this will be center, that is O, or better you call C. So this is nothing but the radius of the track or circular path R. So suppose a body moves on a circular path with a radius R. The speed of the object is given by V. V is equal to speed. Speed is equal to, we know that, distance by time. So speed is equal to distance by time. Here the distance can be the circumference of the circular path. Okay, d, that is the distance, can be here circumference of the circular path. Therefore, we can write v is equal to circumference divided by time. So circumference is given by the equation, that is 2 pi r, actually 2 pi r, and you just write it once again if you want. V is equal to, circumference c is equal to 2 pi r. For a circular track we already know, and hence substitute 2 pi r here and time as t. Therefore you left out with v is equal to 2 pi r upon t. This is the speed, or you may call velocity, formula for the object moving on a circular path. So v is equal to 2 pi r upon t. As I already said that when the object maintains its uniform speed, then it is uniform circular motion. If it is not, then it is called as non-uniform circular motion. We have one more point here, that is when an object is in circular motion, the direction of its velocity keeps on changing. When the object is in circular motion, the direction of its velocity, now we call the speed as velocity because we are counting the direction. So the direction of velocity keeps on changing. So what do you mean by this? Means when the object is in circular motion, its velocity, or you better call its direction, is always changing. So always changing means what? So like this. Always changing means it is like this. Okay. Means, to justify the above statement, let us take an illustration for that. Okay. Take a piece of thread and tie a small piece of stone at one of its ends. Okay. Take a thread and a small piece of stone, tie the stone one of the ends, and by that other end is free. So move the stone in circular path and leave. So assuming this boy tied a thread with stone and he starts moving in a circular path like this. So this will be which means this stone is changing its direction all the time. It is changing its direction all the time. Now if you leave the stone, if you leave the thread, what happens? This thread moves like this. Assume this is the stone moving in this direction. If you leave that, it will not go straight, it will go tangentially. So these are all the tangential lines. Okay, where do you find this? I'll come back to that point later. So when you leave this stone, the stone moves in this direction. If you leave the stone at this position, you may call, so it is like this. It is moving always tangential path to that. Okay, so which is indicating that if you carefully note, on being released stone along the straight line, it moves tangential to the circular path. It moves tangential to the circular path. This is because the tangential path, why it is giving the tangential path, because once the stone is released, it continues to move along the direction. It is move along the direction it has been moving at that instant. So at that instant it is moving in that direction only. That's the reason why the stone, once the stone is released, it moves to the tangential path. So this is showing that the direction of motion, or velocity is changed, and hence at every point it is going to change when the stone was moving along the circular path. So this shows the direction of motion or velocity is changing all the time, okay, when it is in circular path. So this is the reason behind the object is maintaining tangential path, and its direction keeps on changing. I hope you got these 2 points, I mean these things right. So this is the most important part. You can try practically in an open space. Mark my words. This process and this kind of activity must not be performed indoor. It should be outdoor. Okay. So you can try to do this in open area or outdoor area. Okay. This ends the lecture number 20 on motion, and I briefly explained about circular motion, especially the uniform circular motion part. There are still too many things to learn from circular motion part. I skipped because of the what you call the time limit. So I just say this much. So I think these things are enough. Go go through all the videos if you can. And remember, I urge you once again here in this situation, we have settled Google Classroom app. Therefore, go through to the proceedings on Google Classroom. You will get all the videos from first to this, and you will get all the links correctly, and you will have your notes as well as assignments, and hence you can be monitored easily over there. So please do the things there only. Okay, this ends this chapter as I mentioned few moments ago. So in the next period we will start the new concept, that is force and Newton laws. Till then, take care of yourselves. Bye bye.